Vaccines are designed to stimulate the immune system by imitating a viral infection. In the case of influenza vaccines, they are typically created using inactivated or killed virus particles, obtained from various circulating influenza strains. These vaccines contain subviral components, such as hemagglutinin, HA, and neuraminidase, NA. In Canada, influenza vaccines are administered through intramuscular injection. Once injected, these viral components are released into the bloodstream, where they encounter the immune response orchestrated by different immune cells, including macrophages, T lymphocytes, T cells, and B lymphocytes, B cells and B lymphocytes, B cells. A crucial part of the immune response involves macrophages engulfing hemagglutinin and breaking it down into smaller components. After this process, macrophages present the hemagglutinin antigen on their surface, coupled with a specific receptor called the major histocompatibility complex, MHC. This presentation allows T cells to recognize and bind to foreign antigens associated with the MHC. Upon binding to the MHC receptor, T cells become activated and can proliferate into various types, including cytotoxic T cells, regulatory T cells or helper T cells. Activated helper T cells express receptors specific to the vaccine strain's hemagglutinin on their surface and play a significant role in generating antibodies and activating memory B cells. Unlike T cells, B cells can directly engulf hemagglutinin independently of the MHC. After internalizing hemagglutinin, B cells process the antigen and present it on their surface in combination with an MHC molecule. When activated helper T cells interact with activated B cells expressing antigen MHC receptors, they release lymphokines, which have several effects. Lymphokines trigger the proliferation of activated B cells, leading to their differentiation into either memory B cells or plasma cells. Plasma cells are responsible for producing hemagglutinin, specific antibodies specific to the influenza strain contained in the vaccine. Memory B cells are crucial for future immune responses when exposed to an active influenza virus. When an infected individual releases aerosol droplets containing live influenza virus through sneezing, an uninfected person's nasopharynx can be exposed to these infectious particles. If the vaccine strain matches that of the live virus, the hemagglutinin antibodies generated by the vaccine can block the live influenza virus's attachment to host epithelial cells. This can either prevent infection or reduce the severity of the disease. If you found this information helpful, please consider liking this video and sharing it with others. Thank you for watching.